bad. It's just, you know, sometimes hard to find signal. It's bad. Anyway, so let me share my screen with you guys and tell you what we're going to be doing. So share screen. Nothing embarrassing in the screen, hopefully. There we go. So today we are going to be talking about the second part of our animation. Now, if you remember last time, we had Gizmo, right? And the general objective was very simple: animate Gizmo and make it move from the left of the screen to the right of the screen. And for that, we started with the winner's recipe that said, first, go through your data definitions. Instead, before you start typing anything related to your main code, you need to define what are going to be the general pieces of information that you need to condense that are going to make Gizmo. Okay, because Gizmo is a form of data. It's a form of information that contains so far three elements: a X coordinate, a position in the X coordinate, in other words, in the left to right side of the screen, and then a position in the Y coordinate, up to down side of the screen, right? So we talked about this last week. And lastly, we also have a series of still images that the program is going to read in order to animate or give the illusion that Gizmo is actually moving, right? Otherwise, we just have a still image that would move from the left side of the screen to the right side of the screen, right? But it's like dead. There is no motion there. So the point is to animate it. So that's what we were doing last week. So just as a reminder, we defined some things that change in our program and some things that don't change in our program. And that has something to do with how we analyze the information that is going to be part of our main goal, the main program that we are building. So what changes in our program? Well, we defined the X position as one of those things that change, Y position as one of those things that change, and finally the sprites, right? The sprites, remember, are a series of still images that are linked and animated place or render one after the other to give the illusion of movement, right? So we place these sprites into something called a list of sprites. That's how it's called in our program. So what doesn't change? Well, something that definitely doesn't change is the screen size, right? That's something that never moves, that stays as it is, always, in any game, in any animation, right? It would be very, very troublesome if suddenly your game started moving, increasing and decreasing the screen size. That would be crazy. What else doesn't change? Well, there are other constants that are not as obvious. We can go back to those ones. So the point is that at the beginning of your program design, you don't need to know all the variables, all the constants, because your programs change. That's one of the nature of one of the attributes of any program, is that if it is alive, if it is a program that people use, you can expect to add some changes. So you need to make some sort of template that allows you to incorporate any changes in a very easy way. So that is really the second most important thing that I am teaching you right now. So today we're going to start our animation. Well, better say we're going to finish our animation using Pygame. So here is a summary of the things that we did last week. So we created our data definitions, right? And that took like maybe 75% of the space in our program before. So I'm going to show it to you right now so that we can refresh how it looks like. Let me just give me 1 second. So here we go, Python 2, and this is live session. So this is where we were at the end of class last week. So this is what we did together last time. So look at the data definitions that we have. So data definitions start here, right here in line 17, and extend all the way down until here. That's where they end. So look how more than 75% more, most of our program currently is only the definition of our data. Okay, and the rest, the last part, is simply the main script, the main program that we are giving to instruct Gizmo to move. But before that, it's not really like a real not real code, because it's real code, but it's not really the script that we are building. It's just defining the data. Okay, so here you have it. You have a data definition on X, and we defined it from 0 to the size of the screen from left to right, how many pixels wide is our screen, minus the size of Gizmo, right? We need to account for that. Otherwise, Gizmo is gonna reach the edge of the screen and then it's gonna keep going until its top left corner touches the edge of the screen. That's not what we want. We want Gizmo to stop touching or change directions once it reaches the edge of the screen on its right side. And this is what I mean. So let me show you what I mean. So, oh, well, I guess I'll add it later. Anyway, so we created our data definitions before we started coding. And the most important thing that I want you to notice is that we started with the simplest things. The simplest thing that you can imagine in any program that you create is the thing that you write first. In our case, for example, we know that Gizmo has to be somewhere in the screen, has to have an X position and Y position. So those were the first things that we created. And notice how they include primitive data types. In other words, atomic, non-reducible, 4 types of primitives, right? Booleans, text or strings, integers, and floats. Those are the 4 basic blocks that we can use. And then we create our data definitions with that for X and Y. Then we use a string in order to call the location of the image in our computer, which are these pieces of text right here. So there was one for each of the pieces of the animation. We did it together. And finally, we loaded those images included in a new data definition called sprite. And here is where we start our compound data. So up to now, we had all of primitives, all of our data was primitives. But now look, list of sprites is a list. A list is a compound data type that has multiple items, right? It's an array, something that we can go through. And look how each of the sprites for the right side, for the downside, left and up, have their own series of sprites. Give me 1 second. Let me check that there is no one waiting in the waiting room. No. Okay. So after that, we have the list of sprites, basically all the images that together are going to make the animation of Gizmo going to the right. All the sprites, all the images that together are going to give the illusion of the animation going down, left, and finally up. That's what these lists are. So we're going to include each of these lists as an example when we create our last, but definitely not least, because the most important one, data definition, which is Gizmo itself. So Gizmo is going to include an X position, Y position, and a list of sprites that belongs to the current direction that Gizmo is going to. So that's what this means. From primitives to compound, we went from simple to complex. And then we define Gizmo as an example of compound data. Okay, it's basically a complex object that has multiple data definitions inside. The last thing that we did last class was to create a loop that was in charge of rendering the images for Gizmo, which is this part right here. So you can find 2 loops. The first one is an infinite loop, line 93. There it is. So it says while true, a statement that is always gonna return true, right? Because we are not evaluating it or changing it to false at any point. This is called the condition, if you remember. If the condition is always say true, then the program runs forever until you manually finish the execution. And that is the key word, manually, right? So at any point, theoretically, you can finish your programs by just, getting your hands dirty and say, oh, stop, abort, right? You are creating an evil robot or whatever. But the program doesn't have the attribute by itself of exiting its own process. Okay, so this is a forever loop. And inside of those forever loops, for each of the sprites that are being part of Gizmo's animation sequence, we are gonna fill the screen black, then place the image of Gizmo in a given position, and then just, update the position by 10 pixels. This is going to create the illusion that Gizmo is moving from the left of the screen to the right of the screen. There you go. So you can see it going from the left, starting at the 0.0, 0. And then it just, moves 10 pixels every time until it reaches the edge of the screen, and that's where it should stop, right, and go to the opposite direction. But currently it's not doing it. So today we're going to create this behavior. So we need to include two helper functions. Remember what a function is. A function is a way to pack some sort of task and then put it somewhere else in our code. And whenever we need it, whenever we need to call it, we can just say, hey, can you pass me this information, a helper function? And the helper function says, yeah, no problem. And it does it, and it returns a value, right? Or maybe it doesn't return anything, but it definitely makes a task, produces a task. Okay, and so I had given you the analogy. If you are Gru from the Despicable Me franchise, the minions are the helper functions. Okay, so we're going to need two helper functions. One that tells Gizmo what list of sprites have to be run, because currently everything that Gizmo knows is that it has to run the list of sprites going to the right. But if you're going to the left, then you don't want Gizmo to look like he's walking to the right and going backwards, right? Let me show you what I mean. So if I change this right now, Gizmo is going to go the opposite direction. You see? So Gizmo gets out of the screen on the opposite direction, but the animation is wrong because it still looks like he's moving to the right. So we need to update that, and we're going to use a helper function for it. The second most important thing is that we need to tell Gizmo when it is touching the border. So this is going to be the challenge for today, because this is just a matter of, keeping track of what direction you're at. Direction is a data definition that we currently don't have, so we need to include it, right? But telling Gizmo when it touches the borders is not as trivial. So we need to analyze how that process looks like. We need to define how to come to those rules, right? How to derive those rules. So Gizmo currently has the following attributes, and here is the definition, the same one that I was showing you live. So currently Gizmo has a position in the X direction, has a position in the Y direction, and has a list of sprites to be rendered. Those are these three elements: X, Y, and list of sprites. So here is a question for you guys. Which of these three definitions, X, Y, or list of sprites, is telling Gizmo to go right? And the possible answers are obviously those three, but there is a fourth answer, which is none of them. What is the right answer? Is it X? Is it Y? Is it list of sprites, or is it none of them? So what of those data definitions, X, X, Y, or list of sprites, is telling Gizmo to go to the right? What do you guys think? You can type 3 dots if you want to say something. You can also say, I don't know, and that's perfectly okay too. Okay, Neil says X minimum. Excellent, thank you, Neil. What do you think, Claire? What of these elements is telling us that Gizmo is going to the right? Because at the beginning of our animation, Gizmo is definitely going to the right. So what is telling it? X minimum. Okay, excellent answers, you two. So intuitively, we know that has something to do with X, right? Because X is the left to right direction. Sorry, 1 second, guys. Thank you. Something stuck in my throat. It's terrible. So we know intuitively that has something to do with X because it's the direction from left to right. But then it turns out that none of these definitions is really telling us that Gizmo is going to the right, because X, this one right here, just tells us where Gizmo is in relative to the X position. Same with Y. And the list of sprites is is simply telling us which series of animations to render. So none of these three is currently giving us information that Gizmo is going to the right. We need to add a new data definition that is called direction. So we are gonna need to create this data definition, direction, that is gonna tell Gizmo which set of sprites to render at any given point. So there's gonna be 4 cases. Oh, Gizmo, you can go right, you can go down, you can go left, or you can go up. Okay, those are the 4 cases that direction is gonna have. Based on that direction, it's gonna be included in Gizmo, inside of Gizmo's body, if you will. We can create a helper function that is going to use that direction to say, oh, if at any given point, Gizmo is going to the right, then render list of sprites right. Otherwise, you know, change it to whatever is appropriate. That's why we need a direction. So then we're going to also create a helper function that updates the position in X and Y, depending again on the direction. Because if you are going to the right, you're adding to X. If you're going to the left, you're subtracting from X. Up, subtracting from Y, and down, adding to Y. So here is, oh, I put it ahead. Okay, and finally, we need to create another helper function that updates the list of sprites based on Gizmo's direction. Okay, so here is our code as it is right now. Look at it. So this is the actual script, the part that is in charge of changing the sprites, changing the images for Gizmo and making it move to the right. This part simply fills the screen with black color. This part is in charge of placing an image of Gizmo. This part and this part, I don't want you to worry about them. They're just needed for Pygame to run. And this part is the one that is in charge of updating the position of Gizmo. This one is the one that is responsible for Gizmo going to the right. If I subtracted instead of adding, Gizmo would move to the left. Okay, so this part we need to change. So let's look at the example below. So these are the 3 helper functions that we are going to need to implement. Instead, at the very beginning, I want to say, hey, you know, these are going to be the sprites that you're going to be reading through. These are the images that are going to create the animation. The second helper function is down here. I want you to update the direction that Gizmo is going. Because if you touch the edges, I want you to, you know, take a step back and go to the opposite direction. So that's what update there does. And finally, I want you to update the position of Gizmo in the X and the Y direction. This is equivalent to this part that we saw here at the top, but we're going to put it in a helper function. It's easier to edit that way. No, it lows. It lose. What do you mean, Elon? Oh, okay. Sorry, I didn't catch it before. Okay, so let's start first with our Kahoot. I want you to go through the information that I just gave you, but let's do it with this game, with this Kahoot. It's gonna be a nice recap from last week. So I'm gonna share the link on the chat. You want to use the same device that you are seeing me with which you are seeing me, or you can use your mobile device. Okay, so here it is. You can just click on it and enter the code that I'm about to share with you. So I am gonna click here. 1 second, please. Okay, there we go. I'm sharing sound. So the code is up there. So you can just click in there and enter the pin. I see someone being a dot, quite enigmatic. I am getting you together made the sentence. I am getting dot. That's interesting. Okay, so let's do this in 3, 2, 1. Let's get our recap done. Okay, question number 1. What is the data type? The data type of the following data definition. Data type, remember, can be compound data or can be any of the 4 primitives. Those are the 4 primitives down there. Red triangle string, blue diamond float, orange circle integer, or green square boolean. What is the data type of the following data definition? X position. What type of primitive does it have? All right, so we have one of the correct answers. Yes, so that is an integer. And you can see by the second commented line in this data definition, I always put them there. We always put them there, right? X equals an integer. So that is why the value is int. Okay, so whenever in doubt, check your data definitions and check the example that is given in the second line is going to tell you what type of data it has. Okay. Nice. Question number 2. What is the range of values that X can take? The range, remember, the minimum value and the maximum value that X can take. What does X represent? And there are examples there. Red triangle from 0 to 100. Blue diamond from 0 to the screen height. Orange circle from 0 to the screen width. Or green square from 0 to the screen 0 minus agent size. That was a hard one. So that is a hard one to analyze just out of the blue, but I wasn't giving it for you out of the blue. Look at your examples. The first example says, okay, the minimum value that we can take is 0. Therefore, the minimum range is 0. How about the maximum? The maximum is the screen at 0 minus the agent size, which is the size of the screen minus the size of our of Gizmo, right? So I wanted you to look at the examples. What's X min, X max? That defines the range. That's why this last case was the correct answer. Okay. So again, when in doubt, check your examples. That's why examples are so important. Question number 3. Double the points. What data type does pad belong to? Look at pad. What do we have? Pad. Pad has, a series of what? Red triangle, natural, blue diamond text, orange circle number, or green square compound. Look at the second line in this data definition. All right, excellent. So the correct answer is a string, right? AKA text. So we know that a string is a form of text. Good job. All right. That double the points really helped. Next question. What does the data definition pad represent? Now, we defined it, but what does it represent? Red triangle, location of sprites in our computer. Blue diamond, location of my program in my computer. Or green is orange circle, the name of the images to import without pad. Alrighty, so the correct answer is the location of our sprite in our computer. Okay, that is the correct answer. So I see that Wendy just joined the chat. So please remember, mute yourself and hide from, the video chat, just because I'm recording. Alrighty, so welcome back. I'm glad to see you. Just, be an spectator in this Kahoot for now, and then we can, no problem. And then we can resume together. Okay. There we go. It's pretty match. So next question, double the points. Which is not true, about the relationship between a sprite and pad. Sprite and pad are both data definitions. Pad is the one that I showed you before that, has to do with the place, the location of our files in the computer. What are we doing to them now that we are using a sprite? Red triangle, sprite uses pad to load the image into Python. Alrighty. Okay, so this was a tough one. That's why it's double the points. But you can see that, everything is true. Sprite uses pad to load the images into Python. That is correct, right? So we are loading pad. It says right there, load, and then parentheses, and the pad, which was the previous data definition. So that is true. Sprite has the same number of examples than pad. That's also true. You can see all of the different sprites being loaded. Sprite is compound data type that uses primitive pad. That is true as well. You can see in the second line, the commented line of these data definitions, you can see that it is a complex object. What is pygame.image.load? God knows, who knows, right? But it's definitely a compound. The only one that is not true is that these are both primitives, right? Because we know that a sprite is compound data type. Okay, good job. Next question. What is the purpose of the compound data type list of sprites? The compound data type list of sprites. What is the purpose of this data definition? Red triangle, packing a series of sprite data types. Blue diamond, iterate over the list of sprites to create an animation. Packing all animation that belongs to the same direction of all of the above. So correct answer was all of the above. So, but don't feel bad if you just pick one or two because all of them were correct, okay? So they were all really correct. So someone say packing a series of sprite data types, excellent. And iterate over the list of sprites to create an animation. Yeah, the information is there. That's what I really care about. Next question, double the points. How many data definitions does the data definition gizmo include? Without including gizmo. Here is the definition for gizmo. We know it's compound. How many data definitions does it take in order to build its own example? Look at the example in this case, or look at the second line of the code. How many data definitions do we have without including gizmo itself? Red triangle 2, blue diamond 3, orange circle 4, or green square 1. Take your time with this one. There is really no rush. Okay, excellent. So we have one correct answer. So the correct answer is 3. Let's look at the example. Gizmo contains a series of pairs of keys and values. The key is the reference to the data definition, in this case, X, Y, and list of sprites, right? So those are three data definitions. So today we're going to include a fourth one that is going to be called direction, but currently it has only 3 without including gizmo itself. Good job. Next question, how many loops does our animation have? How many loops does our animation have? And here I'm giving you the part of the code that is in charge of animating the sprites. How many loops do you see? Red triangle 1, blue diamond 4, orange circle 3, or green square 2. How many loops? Take your time. All right, excellent. So we have one of the correct answers. Yes, so we have 2. The first one is the infinite loop, while true, and the second one is, so while true, the forever loop is in charge of just running the animation forever. The second part inside the for loop is in charge of animating each of the sprites that Gizmo has inside of the list of sprites. Okay, so those are the only 2 loops that we have currently in place. Excellent. All right, next question, double the points, could be a hard one. Which is not true about helper functions? which is not true about helper functions. They help preparing data to have it ready for the main code. They unpack the data to transform it or update it before giving it back. They are the main part of our code, or none of the above. I think it should say all of the above. Might have been a mistake. Oh, no, it's supposed to be none of the above. Yeah, that's correct. Okay, phew. Whoops. Okay, so the correct answer was they are the main part of our code. The the name kind of gives it away, right? It's there to help. It's not the protagonist, it's not the main character, it's just a second character that is there to make the main character look cool, right? So in other words, the minions for Guru. So the minions are not the main character, right? Well, they gave them their own movies, so I guess they are now, but they didn't used to be. Awesome. We have a dot as the first place today. Good job, everybody. That was a nice recap. Excellent. Okay, so that was our Kahoot, and I'm gonna give you. So it is what time? Time Toronto is 1:33. So we have 1 hour, right? Together. So I'm gonna give you a break. I'm gonna give you a small break, so we can't talk yet. Let me stop share and then pause the recording. It says recording in progress. So let me share the presentation again. So good job, everybody, on the Kahoot. So today, let's get our hands dirty with the code. So I'm gonna get to this later, the rules for bouncing against the edges when we actually need it. First, we're gonna create the data definition. So I'm gonna copy this. I want you to just click on it so that you can join the classroom session. There we go. And I'm gonna click on it myself. It's gonna take me to Replit, and I can see the code that we were working on last time. Okay, so I'm gonna wait for you guys. Just remember, you need to be logged into Replit in order to be able to edit. Okay, I see the first person. I see Nilan. Yeah, feel free to run the program if you want to see how it looks like. Just try not to modify the code itself, because we can break something, but feel free to run it so that you can see what's going on with it. There goes Gizmo. Instead of minus, let's add a plus there. There you go. Let's run it again. So currently Gizmo is moving from the left of the screen to the right of the screen. There you go. Look at that. And technically our program works, right? That there is no error, but semantically, there is something wrong with it. It's like, okay, bye Gizmo. Now what? Where is our main character? It's just gone. So we need to make sure that we make it, bounce against the edges. Okay, so follow me to the line. Where is Gizmo? Line 86. So I'm working on line 86. Here is Uriel. You can see it right there. Okay, it's line 87 or 86, either of those. So we're going to create a new data definition that is going to be called direction. Okay, so this direction is going to be called dir, followed by a modulo sign, which means that, and it's going to contain simply a string value. It doesn't have to do it doesn't have to be anything fancy. It's a primitive type. It's a string. And I want you to think about it as the current direction that Gizmo is moving. And then let's work in the examples. So we're going to have 4 different examples. Modulo can be one of the following. Okay, so can be, if someone knows the answer, please fill the first one, line 90. You can fill it in. I'm going to fill the second one. Oh, we have one question. It's not letting me edit. Okay, Nilon, can you write something in the code in line 90? Okay, so it's letting a Nilon code. Are you logged in, Wendy? You know what? Give me 1 second. Click on this link in the chat, please. Click on that new link. Oh, just try to make sure that you are also writing on the actual, white part in the code and not in the terminal. I see someone writing in the terminal. I don't know who it is. Okay, so what's the update? Were you able to modify the code? Okay, no problem. So just as a reminder, always remember that you also have the recording, right? So I'm sorry that you are facing some issues. Let me know if you're still stuck, so we can take a small break just to help you figure it out. Okay, so basically our direction can be one of four types: R for right direction, D for down direction, L for left direction, and I'm gonna let Nilon finish the last one, the U one. Okay, so let's work in the examples. So the examples, direction to the right is gonna be equal to something. What? Let's just call it R. Direction to the left is gonna be equal to something else. Direction, oh, let's make it down. Excellent, thank you, Nilon. Down, then left, and then finally direction up. Let's make these lower cases. Okay, so can someone help me finishing the examples? They're there, just give them their values. So this is going to be D for down. The last one is going to be U for up. Okay, so just write the last one. Excellent. Yep, so that is technically correct. Excellent, yes. So it's important to be consistent, right? So always keep them in capital letters in this particular case. Okay, so those are the four data definitions. So now what else do we need to do? Well, that data definition direction has to be included inside of Gizmo. So Gizmo currently has the X position, Y position, the list of sprites that are going to be rendered, and now it's also going to have a direction. So how do we call the direction? Let's call it dir. Okay, I'm working on line 105, in line 105. So I'm updating the direction. Direction is going to be equal to, and let's give it an example that makes sense, because the list of sprites are moving to the right, then the direction should be also right. Okay, and I'm going to update this example. Direction is going to be equal to direction. So you can see how I added the new data definition to the Gizmo compound data definition. Now, let's use it. Now, currently, we're going to use that information to decide which list of sprite has to be rendered and when we have touched the edges of the screen. So let's start with our first data definition. Sorry, with our first function. So let's go all the way down. We're going to start working on the main script. The first one is, okay, you know what? When we start the program, I wish there was a function that told me which direction Gizmo which series of images I need to render. I wish there was a function like that. So because I make a wish, I'm gonna call it here. I'm gonna call that imaginary function. I know it doesn't exist. I know, we'll create it in a minute. Update list of sprites. And what is it gonna take? Well, it's gonna take Gizmo, okay, as an argument. And then it's gonna give me back Gizmo. That's one of the attributes of helper functions. Okay, they take something and give something back, often the same thing. So let's create that function. I'm gonna say function definition, and I'm gonna call it update list of sprite, just like I did before. So then let's talk about the signature. The signature is simply a two-piece block that tells me what goes in and what goes out. What goes in? Well, I know that Gizmo, the data definition Gizmo, goes into my function. What comes out of it? The same comes out. Okay, so we say it consumes a Gizmo and gives Gizmo back. So now that I have the signature, I just need a purpose, something that tells other people what this function is for. So, and that is update the current series of sprites. Remember, a sprite is one of the images that make my animation to match direction. There is the key. So define that we're going to create a function update list of sprites. Okay, and take Gizmo as an input. What should we do? There are 4 cases, remember. What happens if Gizmo is going to the right? Let's talk about it. If Gizmo's current direction equals, let's look at our examples, the direction to the right. If that's the case, then what do we do? Well, we're going to update the list of sprites that Gizmo has to render to, which one did we define? Where is list of sprites? There it is, list of sprite to the right. Okay, now someone else help me with the next definition. Elif, what? Gizmo's direction. Go for it. And then Wenli, help me with the next one. It's right there. I'm going to work on the last one. So the next one would be down, right? So first we go right, then we go down, then we go left, then we go up. So for you, Nilon, you need to compare if the direction is going down. For you, Wenli, you need to compare if the direction is going left. Yeah, you had it there. Yeah, that's correct. And then you just make it equal to one case. Remember, you need to use double equal signs because you are comparing, right? If these things are the same. Yeah, you got it. And then just ask for the right direction. Right there, just type dir, lower score, and then make sure that is the one that you want. So Wendy, so here we are gonna call the direction, okay, in Gizmo. So if you go back to the compound data definition that is Gizmo, you're gonna see that it has 4 different items. It has X, it has Y, it has list of sprites, and it has dir. So we're gonna call dir, okay? And then we're gonna compare, that's what the double equal sign is for. If that value that Gizmo has is equal to the list of sprites in a particular direction. So in this case, we have the right case. Nilon is working on the down case. You're going to work on the left case. Okay. If Gizmo's direction is going left, what should we do? Look at the example that I have at the top. You are just going to update the list of sprites for Gizmo. In other words, you're just going to use the same example that I used. Just making sure that the last letter, this one right here, instead of R, matches your direction. Go for it. Good, Nilan. Yes. So this is going to be dir lower score, right? D. And here I'm just referring to one of the examples that we did before. So if that's the case, and then we need to add a colon, right? And down below, we need to say, okay, if that's the case, then what do I do? Oh, no problem, Wendy. Alrighty, so if the direction is down, we want Gizmo, the list of sprites of Gizmo, to be equal to list of sprites going down, right? There you go. So that's basically what we want. So I'm going to help Wendy with the last case because her computer is a little glitchy. It's going to be equal to the list of sprites going left. Okay, so now you can see that we have the 4 cases: going right, going down, going left, and going up. Notice how I use else in the last statement, not elif, because there are only 4 cases. If it's not any of the first 3, it has to be the last one. Okay, so that is what is gonna update the position, the direction at which Gizmo is going. So at the very end, because this is a function, I need to return the value that Gizmo has. So I'm just gonna return Gizmo, okay? So now, if I call this, there is not gonna be any obvious change. So Gizmo is still gonna move from the left to the right. Oops, name RD0. What happened here? Let me check. Oh, someone erased something here. Okay, let's run it again. Okay, there we go. So now we see Gizmo moving from the left to the right, just like before. Nothing seems to have changed. But notice that if I change the current direction that Gizmo has, and I'm gonna say go down, direction down, even though Gizmo is moving to the right, the rendering is gonna show me Gizmo as with the animation that belongs to that one going down, you see? Same with up. Gizmo is gonna look like he's trying to go up, but it's still moving to the right. Okay, so that is what our function is doing. It's just trying to match the direction with the appropriate list of sprites. So that is our first helper function. We did it. Now we need another helper function that is going to be in charge of updating the values in the X or Y direction so that Gizmo keeps moving to left to right, from left to right. And that we are going to call it update. How do you call it? Position, update pos, right? Again, I am wishing there was a function that runs at the very end of my animation, at each step of my animation, so that it makes sure that it moves in the right direction. So here I'm gonna receive Gizmo again, and then I'm gonna return Gizmo. I'm gonna create a new function, function definition, update position. What is the signature? Can someone write the signature for me? In line 125, please write down the signature. Line 125 should have a signature. What does my function consume? What does it give back? Okay, so what this gives, what this receives is the same one as we had before. It's going to receive a Gizmo, and then it's going to give back an updated version of Gizmo itself. Okay, at least that's what we think it does. So we know that it takes Gizmo for sure. We are not sure what it gives back. Let's work on the definition. The purpose is to update Gizmo's current position in X and Y. Okay, so let's create our function, update position, and we know that it takes Gizmo as an argument. So what should we do? Now let's analyze the different cases. It's the same as the ones we had before. If Gizmo's direction is going right, What should I do? Because it's going right, remember. And look at my screen for this. So here I have Gizmo, okay? And Gizmo's position is, it looks like a square. Gizmo looks like a square, but the coordinate that we're referring to is always located at the top left corner of my image. Okay, so the center of Gizmo is not here. It's not. The point that we are referring to in X and Y coordinates is at the top left edge of the image. Okay, so that's why if we keep adding, so here you have the plane. So you have, if you move from the left to the right axis direction, you're moving on X direction. So if you want to move left from where you're at right now, you need to subtract from X. That means that by subtracting from X, you're going to make Gizmo go left. If you add to X, you're going to make Gizmo go right. If you subtract from Y, you're going to make Gizmo go up. And if you add to Y, you're going to make Gizmo go down. So that's the information that we're going to need today, that we're going to need right now. So if Gizmo's direction is going right, that means that we need to add to X. Let's do that. Gizmo direction, Gizmo's position in X is going to be plus equal whatever value, let's say 10. Now we just made Gizmo move 10 pixels to the right if its direction says right. Now, Nilon, please work on the next one. Notice how everything is the same, okay? Direction down, and work on the example here. Wendy, work on the next example that is left, just like before, and work on it here. I'm gonna work on the last case. So the last case is up, which means that I need to subtract from Y. Good. So now we need to write the code. So see what I did with my examples. Sorry, look at what I did with my my cases, and then update it accordingly. So remember, if you're going down, that means that you're adding to Y. Okay, so you need to refer to Gizmo's Y position and add 10 units to it. That's what you need to do. Good. So you need to write the code. So below that comment that you just made, so you know that you need to call Gizmo, right? So the first thing that you do is to call Gizmo. There you go. Now open the square brackets. Excellent. And then refer to what? X or Y? What do you need to refer to? Excellent. So you need to refer to capital Y, right? That's the name. Excellent. And if, well, and then just add to it. So you're gonna say plus equal means take the current value of Y and add 10 values to it. There we say 10. Excellent. Yep, excellent, excellent. So this Y doesn't go in there, but there you go. So now you finished your case. So Wendy, the same thing, but your case is a little different. Does it affect the X position or the Y position? So you're gonna need to also call Gizmo. What goes inside here? Is it X or is it y? It should be x. And because it's going left, we are subtracting from x. So this is going to be minus equal 10. Okay, so those are the 4 cases. That's our helper function. Excellent. Thank you, Wendy. I saw your message in the chat. And finally, remember, this is very important. We need to return something. What do we return? We're simply going to return Gizmo. Okay, it's right there in my signature. It consumes Gizmo, it produces Gizmo. So now I am gonna simply update Gizmo in whatever direction is moving. Now there is one last definition, one last function that we need to create. I wish there was something that told me if that made Gizmo change direction if it touched the border. So let's create that function. I wish there was a function that was called maybe update direction. Okay, and this function would take Gizmo and it would update its direction depending on whether or not it touched the edge. So let's create that last function. Function definition, update direction. This is one of the most important ones. It's still a helper function, but it's very important because direction affects the position and the list of sprites that are going to be rendered. So we need to be very careful with how we modify this particular parameter, this particular variable that is direction. So what goes inside? What's the signature? Can someone help me with the signature? The signature is the same, right? So we take Gizmo, we give Gizmo back. What else? Well, the purpose is to update Gizmo's current direction, right? Current direction. If it touches the edges. Let's define that function, update direction. We take Gizmo. This consumes Gizmo. Now, what should we do? So in the previous functions, notice how we work on the 4 different cases. When Gizmo is going right, when Gizmo is going down, when Gizmo is going left, and finally up. Okay, so those 4 case scenarios should also apply here. But in this case, we're gonna change Gizmo's direction whenever it touches the edges. So I'm gonna show you on my presentation in PowerPoint. These are the 4 different cases. These are the 4 different situations in which Gizmo touches the edges. If the right corner of Gizmo's position in X touches the right wall, sorry, one second, the right wall, then a change of direction has to happen to the opposite direction, this which is left. So as I mentioned before, Gizmo's current X and Y position is on the top left corner, which means that we need to, in order for Gizmo to go the opposite direction once it touches the edge, is equal to add Gizmo's body size, which we call agent size, in X. There is a variable called that, there's a constant called that. So that is going to be the point in X plus Gizmo's body. Therefore, considering this point in X, not this one, but this point in X, so that whenever it touches the right edge, goes all the way down, all the way right, and touches this edge, it's going to say, oh, you know, the right side of my body just touched the right edge. Therefore, I need to go to the opposite direction. If we just count the current X position, Gizmo is going to keep going a little bit more until it just, you know, gets out of the screen. And then it goes back. So that's not what we want. We want Gizmo to move to the opposite direction as soon as it touches the edge. Okay, so that is going to be the first case scenario. It's this one right here. What's the opposite scenario? Well, if the left corner of Gizmo's position touches the left wall, I want to change the direction to the right. So in this case, because the position of Gizmo is at the top left corner, There is nothing before that. There is no part of Gizmo that is before that. Therefore, it's okay that we compare directly that value without considering the agent's size to see if it touches the left side of the screen. And if it does, that means that we just need to go in the opposite direction. Now let's look the cases for up and down. If the lower corner of Gizmo's position in Y touches the down wall, change the direction to up. Here is the same case scenario when we were going to the right. We have the point in X and Y here. But notice that we also need to consider the Gizmo's height, right? Which is called the agent size Y in our program. And by considering this, as soon as Gizmo's body touches the down wall, it's going to say, uh-oh, I am out of the boundaries, and then it goes up. The last case scenario is when it is at the top, because that's the X and Y coordinates, same as with the left direction. Then we just need to compare it directly without taking in consideration the Gizmo's body. Okay, so those are the 4 different case scenarios. So let's program that. Let's start with down. If Gizmo X, current position of Gizmo in X plus agent size in X is bigger than the size of the screen at 0, which is the width, what should we do? So there has to be another if statement before. If Gizmo's current direction, oh, actually, let's leave it like that. Let's see what happens. Okay, so if my position in X plus my body is bigger than the right edge of the screen, what should I do? Well, I should probably go the opposite direction. So I'm gonna say Gizmo's direction is gonna be equal to direction to the left. Okay, what else? If Gizmo in Y, so this was the right case, okay? So I'm gonna put it in there where someone is writing right now. So this is right case scenario. Let's work on down case scenario. If Gizmo in Y plus agent size in Y is bigger than the size of the screen in Y, which is the height, what should I do? Well, the current direction that Gizmo has is going to be equal to up. Okay, because we know that we were going down. So the direction is going to be up. So this is the down case scenario. If someone feels like it, feel free to work in the third case, which is left. I'm going to work in the last case, which is up. Okay, if Gizmo at Y equals is less or equal than 0, that means that Gizmo's position in Y has touched the up edge. So Gizmo has to go in the opposite direction. So the direction is going to be down. Okay, so nobody wrote here, so I'm going to finish it. So this also involves X. This is left. So if this Gizmo is less or equal than 0, then Gizmo's current direction is going to be equal to the direction to the right. Okay, so those are the 4 case scenarios. They look a little complicated, but it's just because they are not as obvious, right? So this is going to be the left case scenario. And finally, the right case scenario. Can someone do me the honors and please run the program? Let's see if it runs. Non-type object is non-subscriptable. What happened? Remember what I told you that you always have to return something? Well, turns out that your instructor forgot to do that. So we need to return Gizmo, right? There you go. Can someone run it again, please? There you go. What happens now? Oh, there goes Gizmo. It goes to the right. Boop. Uh-oh. Well, something happened there, but you know, it's touching the edges and now it's bouncing back. So that's the behavior that we wanted it to have, right? So let's see what's going on here. So Gizmo is going to the right, touches the edge, and then goes to the opposite direction. So when Gizmo, let's look at the situation when Gizmo touches the right case scenario. So we're saying Gizmo go to the left. Uh-huh. And somehow it's going up. Why is Gizmo going up? Oh, it says there. I don't know why is Gizmo going up. Okay, so let's stop it. Anyways, so we can just debug in a minute, but the important point is that the main structure of our program is in place now. So anything that we want to do to Gizmo, we can do it by simply updating our data definitions, which will naturally allow us to modify our functions, which naturally will allow us to modify our script. Okay, so here you have the three helper functions. One is in charge of updating the list of sprites that Gizmo is going to have, depending on the direction. The other helper function is in charge of updating the direction of Gizmo. And the last helper function is in charge of updating the X and Y values of Gizmo. X0, I don't understand, Aaron. Okay, so now our program runs with some errors. That's fine. It's to be expected. Nothing wrong. Nothing works the way you expected it at the first in the first time. But what do you think if we, like create a better version of this program very quickly? What if I wanted Gizmo to randomly decide when it wants to go into a different direction? Because currently, Gizmo is moving from the left of the screen to the right of the screen, and that's it, right? It's going to the right, and it's going to the left, but there is all the space below that we are not really exploring. So if we wanted to make a game, Gizmo has to be able to move in 4 different directions, not only 2. Oh, no problem. Okay, so how do we do this? Well, it turns out that the way that we build our program allows us to easily, very easily, emphasis on the easily, to create this new behavior. So let's create a new data definition. What is this data definition gonna do? Let's call it counting steps. And what counting steps is gonna do, count steps, is gonna be equal to an integer. What this is gonna do is simply count backwards how many steps Gizmo has made, so that when it reaches 0, we changed randomly the direction in any of the 4 directions. Okay, so randomly, it will be a counter for Gizmo's steps. And I'm just going to include one example. It's going to be equal to count STPS 0 equal to 15. That 15 means 15 steps. Okay, so now I'm going to include this parameter inside of Gizmo's compound data, just like we added the direction to Gizmo's data definition. I'm going to add now counting steps, and I'm just going to call it steps. Okay, and it's going to be equal to, well, count steps. That's it. Now, what should I do? Counting a step. Okay, so I was working in line 105. Let me see what, all right, so we updated Gizmo. Now it has a new value that we can call. So what should we do? Well, naturally, like if you look at our while loop and for loops, we included three helper functions. One that modifies the list of sprites, one that modifies the directory, and one that modifies the X and Y position. In other words, all of the elements of Gizmo's body are being updated using helper functions. So it's just natural that I could create a new helper function that modifies that new data definition, which is counting steps. So I'm gonna go to the line 166, the very last one. I'm gonna say, oh, Gizmo is gonna be equal to update the steps. It's gonna take Gizmo as a parameter, okay, as an argument. So let's create a new helper definition. Function definition, update steps. Signature, what goes inside? Gizmo, what comes out? Gizmo as well. Very simple, very straightforward. What's the purpose of this function? Well, evaluate the position, evaluate or update counting steps and change direction when reaching 0. That's all it does. So let's create our function definition, update the steps. And it's gonna take Gizmo. And now, should we have 4 cases? No, not because counting steps, the last data definition that we made, is only an integer. The only thing that it has is a number equal to 15, right? The number of steps that Gizmo can count backwards. Therefore, we are just gonna treat 2 cases. When counting steps is equal to 0, and when counting steps is anything different than 0. If Gizmo steps equals 0, what should I do? Otherwise, I should do something else. Oops, sorry, wait a minute. Something else, okay? So what should I do when Gizmo's steps equals 0? Well, the whole purpose of this is so that Gizmo can change direction randomly. So I'm gonna say Gizmo direction, oops, is gonna be equal to, and then I don't know, how can I make it choose between 4 different directions randomly? Well, I know that there is a library called random. We're gonna use it in a minute. But for now, I'm gonna write 3 exclamation marks there so that it is obvious that I need to go back to work on those. Otherwise, if this is not equal to 0, well, I want to reduce the value that the steps has by 1. So it's going to be equal or minus equal 1. Okay. So now let's work in that random behavior. So I'm going to import at the very top. I always put the modules that I'm using. It's just consistency. It's good practice. So I'm going to say import random. Okay, and now I'm going to use it. I'm free to use that library. So I'm going to go back to that function definition with the 3 exclamation marks. And then I'm going to say random dot choice. Okay, this is going to pick from a list. What items are in that list? Well, the 4 directions. Direction to the right, direction down, direction left, and direction up. There we go. Now, finally, because of our signature, we know that we need to return something. That is Gizmo. So let's see what happens if I run this. Whoops. Only then does not match any other indentation level. What happened here? Oh, someone uncommented the past program. Okay. There we go. So we count 15 steps and look at Gizmo. Look at him go. Now it's moving randomly. It's going up, down, left, etc. Okay. But the point here is that the only thing that we needed to do in order to increase the behavior of our program was to work from the simple data definitions, which are the primitives, assign it to the compound data definition, which is Gizmo, and then work with the cases using a helper function. Those three things are the only things that we had to do. Okay, so I'm gonna take a small break right now because I want to ask you questions. So do you guys have any questions? Is everything clear or are you guys lost? How do you feel? Okay, so just as a reminder, we applied the 4 different cases to update Gizmo's position in the to update Gizmo's direction. Nilon, okay? Okay. Okay, anyway, so this should be recording. Yes, so all of this session is being recorded, right? So you're probably gonna need to go through this maybe once or twice before it starts, like just fitting in the different areas and it starts making more sense. But it's normal if you feel that you're a little stuck. That's the process of learning. That's why our brain hurts, right? Sometimes. But anyway, so we started from the program that we had last class, and then we included helper functions to separate tasks that affect different attributes of Gizmo. So Gizmo had these 4 different attributes, right? So it had an X position, Y position, the list of sprites to be rendered. This is X, this is Y, this is list of sprites. And then we added 2 more. We added direction and we added steps. Notice that these ones required a helper function. This one required a helper function. This one too. And this one as well. So at the very end, notice how at the we have four helper functions. These 3 and this last one right here. Okay, so I'm about to let you go. I'm about to finish the class. Before I do that, I need to share with you the homework. So the homework is this program what we just did, but you're gonna include a functionality to it. Okay, don't worry, it's just 2 lines of code. I'm not gonna ask you to do like all this crazy thing, but here we go. It's homework number 6. So I want you to do the following. Please pay very close attention. I'm gonna paste a link in the chat that you're gonna click on. Once you click on it, it's gonna give you the option to fork the project. Okay, it's a button that says fork. And let me see if I can show you in the screen. There it is. So there is a button on the top right that says fork REPL. And if you are logged in, you're gonna be able to create an exact copy of this project in your own Replit folder. Once you have it in your Replit folder, I want you to work on it. This is how it looks like. These are the instructions. Homework number 6, update your data definitions to include a random behavior, just what we did. So do the following. Create a data definition called steps run that represents a maximum value of steps that Gizmo can walk before changing direction randomly. Then you're going to need to update Gizmo to include that new data definition. Then you're going to need to simply run the program. And once you run it, you're going to need to answer me these 3 questions. That's all you need to do. Okay, and if you scroll down, you're going to see that there is a sandwich of commented words, one that says start coding here and one that says stop coding here. You could technically finish this assignment with only 2 lines of code or without including comments. Okay, but what I'm asking you to do is to create your data definition. Hey, data definition steps run. What does it include? I'm gonna call it STPS run equals what? An integer, a Boolean, etc. Okay, and based on that, give an interpretation and finally work on the cases, just like we have been doing so far. Okay, and at the end, I just want you to add this data definition in here, and you're gonna call it steps, just like we did. The steps is gonna be equal to the steps run. Okay, so notice how you only need to include 2 lines of code. This example and this modification to the definition of Gizmo. Okay, and after you do that, your program should run perfectly fine. Okie dokie, so I'm gonna stop share right now. And I'm gonna stop the recording.